Greetings, this is Edward Ojambo. Ojambo.com has an article about HTML5 game physics, acceleration, and elastic collisions. The link is ojambo.com/html5-game-physics-elastic-collisions. And as usual, the entire source code and everything can be found at ojambo.com. You can expand the source to see it. And we're just creating something as the demonstration, the collision, which will be the bottom. So in this case, we'll be talking concepts will be acceleration and elastic collisions for this part of the tutorial. So if you ever need web or mobile applications, you can visit ojamboservices.com. That's ojamboservices.com in the Toronto, Ontario, Canada area. Okay, so going to run basically what we left off from the last tutorial. Basically, we just have a canvas character and position which just goes horizontally from the left to right. So using the exact same code, we're going to add a few modifications to it. So first thing we want to do is say before is the acceleration and collision detection. Okay, so let's do game physics, acceleration, and elastic collision. The styles will stay the same. We made it green just so that we can see where our borders are. And we're going to make a change. We're going to make the vertical velocity 0 because we're just going to be going up and down for the gravity. Everything basically stays the same. We're going to update every 20 milliseconds. And in our draw function is where we're going to make our modification. So the velocity is going to stay the same as for the position. This is where we're going to add the new features. So first thing we're going to do is we're going to add the velocity. We're going to add the drag coefficient, which is friction. Basically, when it's being dragged down, we don't want it to be very uniform because that's not realistic. So this also depends on your character, but 0.99, just about 99% is very good for 2D characters. We're not applying one to the x to the horizontal vertical velocity because we're only going up and down for this tutorial. So for the gravity, I'll apply it again to the vertical velocity, which would be 0.25. This is usually based on the object size and its velocity. For this particular character, that's a pretty good one to use. And then let's run this to see what it looks like. As you can see, it's a little bit faster than the previous falling down. So now we're going to add the collision. If you notice, it just falls right through and continues. So what we want to do is we want to detect the first collision, obviously be the bottom, which will be the canvas bottom part. So we want, because the measurements start at the top, so that's why we need to add the character height to its y value position. So what we want to do is we don't want it to fall through the canvas. We want it to, minimum should be right at the bottom, which would basically be the canvas versus the height of the character. That will be the most bottom position it can be. And the velocity will basically be this is where our collision detection is. Basically, as soon as it hits the bottom, we want it to, the velocity should change a little bit, so it gives it a nice bounce effect. Okay, let's run that and see. Before we do that, let me just change this up here so you don't get confused what tutorial we're in. So this is going to be acceleration and collisions, elastic collisions. So let's run this. You can see when it bounces in the bottom, the velocity changes a little bit, acceleration changes as well, and as you can see, it's going small and small and small and small, which is more realistic. Okay, I hope you find this tutorial useful. The entire tutorial, including the source code, can be found at ojambo.com. Please visit and leave feedback.